Welcome back to the Mr. G's EV Hangout. This is where all the rising tide lifts all boats. We're here to talk about electric car conversion and off-grid systems. Tonight, we're going to be talking about batteries, your options, performance batteries, sizes, shapes, all different packs, suppliers, recommendations, and whatnot. We have our round table. We've got Tom Summers in the house. We got Kevin Lieberman. We got Talik is here, and Joe Roth has joined us. But I first want to tell you that today's episode is sponsored by Mr. G's Workshop. And that is a shop in New Jersey. I'm a high school auto and metal shop teacher, and I opened it up so that I am the shop teacher for everyone. So you can take Welding 101. You can also take electric vehicles. There's also a class on engines, believe it or not, small engines. And we have all kinds of classes coming up in the summer and also in the fall. So check us out, rongrossinger.com, Mr. G's Workshop. I'm going to send it over to Talik because we do actually have another sponsor that is involved in safety of electric vehicles. Talik, what do you got for us?
So, yeah, if you've been watching the podcast for the past 3 weeks, you may have seen our EVject episode. If you're stuck at a supercharger and some homeless person or some threatening person comes up to you and you need to get out, you press stop charging, and this product allows you to drive away. It breaks away like you're about to see here in the product demo. The Cybertruck's going to roll away, and the vehicle can escape, and the charge cord is undamaged. So if you want to order yours so you can be safe, use our code EV Hangout 10 to save 30% on your safety adapter. Check them out.
Cool. And if you want to know more about that product, we did a whole interview about it. It's very interesting from a product design, but also from a safety point of view. All right. So tonight we're going to be talking about batteries. Actually, on location at the EVLC. Why don't we swing it over to California, coming to us live. We got Kevin and Omar, and they're right next to the famous EVLC bus. This was built in 5 weeks with all volunteer team. What kind of batteries are inside a project like that, Kevin?
None right now. There's joke.
They're all getting balanced externally. So for this particular bus, we worked closely with EV West on this, and they had a very nice package which puts 6 Tesla modules into a VW bus. It goes into this box. The box lifts right up in there. And can I get to the box easily? Not really. And mounts nicely. That gives you a 36S battery, 36 times 4.2 volts fully charged is about 151 volts. And works perfectly for the Hyper 9 motor, high voltage Hyper 9 motor we have in this bus.
And Kevin, that's the reason there's only 6 is because we got to get the voltages right for that motor, right? Because a Model S has 14 or 16 modules, correct?
Right, and that's more like a 400 volt system. And
stop that.
It's yeah, so that would be a full 400 volt system. That's like a 96S. This motor only requires 151 volts, and I think it limits at 160 or something like that. So 6 is the magic number. Now we could have paralleled 6, and there's a partner of ours that wants to do this on his bus, but we're not sure if that's going to work yet. It certainly makes things more complicated. So the batteries in series gives us the voltage we want, but maybe not quite the capacity we want, not quite the range. This bus now is about a 70-mile range when you're on the highway, and we found it's not quite enough.
So yeah, so for tonight, since we're talking about batteries, you know, as we're going to discover, there's so many different options available now. But you also, it's not just about picking like the chemistry you like or the shape that you like. It's about also matching up your voltages and amperages to work with your motor system, right, Mr. G?
Yeah. So, you know, it's kind of like, how do you want to slice this up? Obviously, if you took, I don't have it with me, but let's say this was a battery as a soda, and if you put them in series, you could add up the voltage. Let's say nominal would be 3.7, or they like to say 3.65, and you could add that up to get to your 100 or so in or 150 in series, but you won't have the capacity. So you will have the voltage because you're going in series, 1, 2, 3, 4. You're adding up, but you won't have the capacity where you go wider, and that's where the parallel comes in. And just on the basics. So if someone's listening to this and they already know how a Tesla module has it all set up, then we're going to get to the more advanced stuff and more options soon. But just to review, on a Tesla module, believe it or not, it is 74 in parallel, and then it is 6S, so 6 series, which gives you about 25 volts. But then you need, if you're going to do a 150 volt pack, you're going to need 6 modules, and each module, oh geez, what does that weigh? Off the top of my head, I don't know. What does it weigh? 40 pounds or so?
55 pounds per module.
55 pounds per module. So, and then you also have to figure out where you're going to put it. So these are the considerations that you have to think about when you're designing a pack. There's also another way to do it where you could design your own pack. You literally could make your own. Jehu, back in the day, pioneered a lot of that stuff. He would actually solder and make his own connections, and he would make his own battery packs using these little connectors. They still sell them. Mostly in the e-bike industry, people tend to do that. And then but imagine if you have the patience, you could build your own battery pack. The nice thing about the Tesla is it's already all put together. And also you need to have an enclosure because you can't have water hit these things. That would definitely short it out as well. So
I've got this Tesla module right here. So yeah, the advantage is this was all soldered by robots and quality tested and all this. You don't want to make one of these by yourself anymore, zapping individual cells together. There's no way that you're going to get the quality of something like this. These are really nice. Another key consideration of a battery module too is the BMS connection. You need to be able to monitor each individual set of cells within this module. Tesla modules and a Model S make it real easy. With this breakout board that's sold by EV West, you can get to all these connections, and they make a nice connector that plugs right into your BMS to monitor all these batteries. So it makes it really nice and easy.
Yes, that's true. So yeah, on a basic level, you should know what parallel versus series is, and you should know what a battery management system is. We just assume that people may or may not know what that is. So if you don't know what a battery management system is, just think if you have a flashlight, you have 2 batteries in series. The total on an alkaline battery would be, let's say, the total would be 3 volts on an alkaline battery. But what if they were chargeable and one of them was at 1.4 and the other one was 1.3? If you charged it, you might hit the top on one of them, but not the other one. And so now if your total is not 3 volts, then you keep on charging. You could overcharge one of your batteries and undercharge the other. And that's when you're going to get into potential fire. So the management system sees the voltage and says, nope, you're at the top, so you can't charge anymore. So really you need all your cells to come up in balance. And that would be the quick overview. You want your cells to be balanced. A way to do that would be to, before you put it in the car, is to balance them. Kev, you guys got a video or you could show that you're balancing right now?
No, because we're still making our harness. So we have we have an active balancer here, which we're going to do to get our over discharged Tesla batteries back in action. We've charged them up individually, and now we have an active balancer, which will take the voltage from the highest cells and put it into the lowest cells and get them all even. So
oh, wait, get out of here. Wait, that's a big deal. I've never actually seen an active balancer. So just so people know, a passive balancer burns or uses a resistor to waste the top cell that's too high and get it down so it's balanced. But you're saying you can actually take energy from there and charge the low one, bringing them into balance quicker.
Yeah, that's the idea. And you're not just burning energy off, you're actually shuttling the energy around.
That is awesome. And where'd you get that?
It was actually Doug that turned me on to these things. This is the Haltech balancer, Doug.
Haltech?
Yeah, I've seen them as cheap as $40 recently. Yeah. Do 24 cells.
No way.
Yeah,
and in fact, you can daisy chain them. I've got 39 cells right now in my VW, and it's I've got 2 of them doing 39. Just the very last one in the series, you hook it as the first one in the next series, and then it all balances 39 cells.
This is what I'm talking about. This is what the podcast is about, is we get the right brains coming together. Wow, I had no idea this was even for sale.
Yeah, they're called NEY, N-E-E-Y, NEY. If you look up the NEY 4-amp smart balancer on AliExpress.
And that's also going to do it a lot faster, right? Because it's not going to, we're not talking milliamp hours here. We're talking amps, right?
4 amps.
Yeah, so that's going to balance a lot faster.
Here, this is the Enter key, which is they're all clones of each other. But here's the big thing. They do great, and I totally trust this on my bench as far as I can throw it to go balance. But I don't want this in my car. Maybe it would be okay. The thing is, it's Bluetooth controlled and wireless only. And I'd prefer to have a hardwired CAN connection for my balancer.
That's it.
Yeah.
Oh, that's basically it. Yeah, basically.
So the other thing is, again, if you've been watching the podcast or if you haven't, we actually have a whole episode way back. I think it's episode 5. Was that with Thunderstruck, right, Mr. G? We had a whole thing where we talked about BMSs. So we have a whole episode dedicated just to BMS. Go check it out.
Yeah.
Yeah, we don't want to get too sidetracked here. So
yeah. Well, this is pretty incredible. I didn't know about this. I would like to try this out. Yeah. Haltech, very cool.
So what we're gonna do? Yeah, these were.
And the old ones are Haltechs. The new ones are called NEY, N-E-E-Y. They're 4th generation. The normal price on them is about $75, but they were on sale a little while ago, and I bought a bunch for people in our club. They were like $45 a piece.
Okay. And can you put it in the chat, NEY, where I can find that?
I don't know how to do that. I'm sorry.
That's all right. Oh, I think I found it. N-E-E-Y.
Yeah, they're the 4-amp. NEY makes a bunch of different balancing products. The ones you want are the 4-amp, 4A smart balancer, 24S, 24 cell.
There it is. I think I found it.
And just look around. AliExpress will have different suppliers, different resellers, you know, whoever's got the cheapest.
So, but be careful. It's not $11. And I made this mistake. The extra wiring harness that comes with it or something is $11. And it automatically shows you that lowest price. That is not the price of a balancer. That's a price of one of the pieces of the balancer.
Yeah.
Mm-hmm. Would that be this one?
Looks like it, yeah.
Yeah, I made that. Just click on it, and then there will be several selections. You know, you scroll through their offerings, and it'll say one of them's the harness, one of them's the balancer itself, etc. The balancer does come with a set of wires, but if you want an extra set, like I've got a Sparrow, and I've got that wired up for one of these balancers, so I can use the same balancer on my Sparrow as I can on my VW. I can switch them around, you know.
Very cool. Very cool. And so does it balance faster? Is that the idea?
It balances well, and I don't know about faster, but 4 amps is pretty fast.
Yeah.
And also the power draw on it is minuscule. I've had it on my VW for months, and it's barely drawn down anything because it doesn't burn off power. It transfers it from the low cell to the high cell.
So by faster, we can balance more modules at a time. So I think this one set up, we can balance 4 at a time.
Another thing is you only want a top balance. You don't want it balancing all the way down through the complete curve, discharge curve. There's a minimum that you can set. Stop balancing when you reach 3.2 or whatever, and so it doesn't balance all the way down through and then back up. It just balances while you're at the top. I have one on my house bank. I just made a 19 cell house bank, and it's been stellar.
That's great. Well, this is good stuff. So, yeah, I think this is something that came up a bunch of times when we talked about. Everybody usually says when you talk about battery management, even someone who just learned about it will say, well, why do you burn off the energy? Why don't you just take the high energy and put it to the low energy? And so now that's called active, and it's great. There's products out there now. That's fantastic.
I've got something too to say about the Tesla cells. And by the way, Joe here is pretty much an expert on Tesla modules.
Cool. Go for it.
I just bought an El Camino that had been converted to electric, and I think originally when it was converted, it was like 180 volts. Well, somebody put 5 Tesla modules in there at about 125 volts, which is fine for a 3,200 pound car. It's got an old DC 11-inch motor in it, warp 11, and Tesla modules sag like crap. They sag severely. So when I stomped on 125 volt Tesla cells, it dropped to about 80 volts. And that's not enough to drive a 3,200 pound car. So I'm I took the Tesla modules out and I'm putting in LG Chem. I'm putting in 10 LG Chem cells, 2P5S. And that's 330 volts. So, yeah.
Oh,
anyway,
okay.
Your controller will handle that. So
just beware the sag. If you use Tesla modules, beware the sag. It's on the order of 35–40% when you're drawing hard from.
Yeah. I think because the thing is, they're meant to be in a 400 volt system. So
right.
They're not meant to put out 400, 500 amps. They don't like to do that. So the same way I've killed all my e-golf battery modules, the same deal. They're meant to be a 400 volt system and probably 200 amps, but I routinely pull 400 amps out of them.
That seems like a good topic for down the road discussing that.
Yeah. So you're basically, aren't you talking about the C rating basically? How much can you pull before it's really not meant for that?
Right.
Yeah. 1C would be its amp hour rating. So if it's a 100 amp hour battery, it's meant to pull out a maximum of 100 amps. But it's just an example. That's not what the Tesla modules are.
Like the 18650s in general are between 2,500, 2.5 to 3.5 amp hours. Let's just say 3 amp hours. So if you're pulling 1C, you're only pulling 1 amp out. 3 amps out of each, and that would be a C. That would be a 1C. But you can a little bit more.
I've heard that 15 amps is like the max on those, but
yeah,
it depends on how much time. So,
Joe, we got Joe on the call. Joe, what do you think? What's the C rating on the 18650s that are in the Tesla?
Although I have a healthy opinion of myself, I think Doug mistakenly gave me knowledge on batteries which I don't have, so I couldn't answer your question, unfortunately.
Oh, no problem. I just thought if you wanted to weigh in, I wasn't putting you on the spot. It's all good. Yeah, I mean, we're all learning, so it's a community.
Yeah, so I mean, the idea is that the Tesla battery modules are not the magic bullet. You have to have the right application for them. And in Doug's case, it wasn't the right application. He's going to a more power dense battery.
Yeah, I mean, the El Camino is like a muscle car, and
It's heavy.
you only have a 5-pack. Yeah, I just instinctually that doesn't sound right. I do see what you're saying, but yeah, for that you probably want an abundance of power, because there is a perception, which we'll just go into for a second. There is a perception, and Michael Bream, EV West, I think, should have the credit for making sure that you either double or triple the horsepower or don't do it. And so, there's a perception with a muscle car that you could break the tires free in any, in the first and second gear, basically. So yeah, don't underpower your vehicle. I think that happened a lot in the beginning because of there weren't that many options, and also it was to prove the point. So the first conversion I did was lead acid batteries, and it was 144 volts. We had 12 batteries from the marine industry, and so you're carrying on 1,000 pounds of batteries, and you're not getting that many amps out of it because it's just sagging completely. But now you should be able to rip the tires free. Not that that's the goal, but you should have a healthy amount of power, and I think that would be the winning formula there. So
we're kind of mainly staying in the automotive conversion selection conversation right now, right, Mr. G?
Yeah, we can move over to off grid a little bit.
Well, I was gonna say before we talk about off grid, since BMS got commingled in this topic, so does motor choice, or maybe you're inheriting a project that has another motor. So maybe let's talk about which modules or which types of batteries go well with which types of motors. And so we kind of have the usual suspects. You have a Tesla large drive unit, small drive unit, the Model 3Y motor. You got your Hyper 9. The warp ones, those are DC motors, right? So we want to mainly talk about AC motors tonight.
Basically, you're either doing, I tried to simplify it recently. Basically, you're either doing an engine swap or you're changing the drivetrain. If you're doing an engine swap, you're just going to put like an AC motor in that kind of has similar or maybe more horsepower than you had originally, maybe a 4-cylinder. And then you're going to put in an AC motor like a Hyper 9. But if you're doing like a drivetrain swap and you're putting a Tesla motor in, you're changing the architecture of the vehicle. But now you need 400 volts. So where are you going to put all that? Can anybody talk to a small package that has the high voltage? Maybe we should go there. Okay. Talik, go for it.
So recently, the small packs, so we're talking small capacity. There's a conversion out there called Torque Mountain. It's a Jeep. It's a Willys Jeep. He put a Volt with a V, a Volt battery pack in there, matched up to a Tesla Model 3 motor, because the Volt, even though it only has about 18 kilowatt hours, it's configured to be about 350, 400 volts. So he can match up. It fits neatly in the T shape of the pack. So that's one thing to check out. There's a Renew episode on that Jeep. But if there's also out there, we have the video of the land speed record Revolt systems, reconfigured by Revolt. It's actually been out there quite a while. But they used a bunch of Honda hybrid batteries to get up to the right voltage. So that's high output, but not exactly the biggest capacity. Do you have that video up, Ron, ready to go?
Yeah, I'm just pulling it up right now. And I'm going to head over to Gas and Go with Snow to get this coverage. What a great channel. We got Snow from Revolt doing some great coverage. And they just broke a world record.
On dirt.
Check it out.
So just to clarify, this is the world record on dirt. They're going to go for the salt record soon at Belleville, but this is now the dirt bike, the electric bike on dirt record.
Cool. Yep, I can actually mute myself and we can hear them talk about the batteries for a second here.
Yeah, so they're about to take the cowl off and talk about the battery that's underneath here.
All right. So here we have a stripped down version of the same bike. And one thing I want you to take note is the dust. This is after it's been blown off. So this is how much dust it picks up at El Mirage. All right, so now tell me about this battery pack. So I'm looking at individual cells here.
Yeah, so the car that they came out of has 96 of those. We have 456 of
so
those.
That's a lot on
it's
insights.
114P, sorry, 114S 4P. So that battery pack will do 800 volts at 480, sorry.
Okay, 450 volts?
Yeah, 480 volts, 800 amps.
All right, and this is...
That's the inverter.
Box?
Yep.
So the inverter. And that basically takes your DC voltage from that high voltage pack and makes AC to turn the motor. And now what exactly is the motor? Can we flip this guy around?
Yeah, let's do.
So it's got a UQM motor in there. You watch that whole episode. It's really cool. Yeah, Gas and Go Snow. He covers all sorts of vehicles, but he works at Rebuilt. And that Matty right there, he's the driver or rider, and he's the one that was on it. But anyway, so as you heard, they corrected it to where I think he said 480 volt, 800 amp. So they have pretty high power output, but not a lot of capacity there.
Right. They're not going to the grocery store to pick up milk. They're not going for a cruise in the mountains. This thing's meant to go straight, go fast. So they don't need a lot of capacity, but they need to be able to unleash that power quickly.
What was the, they said how many in series and how many in parallel? What did they say?
So originally it was 96, but now it's like 104, something like that. Okay. We can go back and listen to it again.
Probably.
Yeah, I lost between him going back and forth because I think he was flipping. But you see there's basically 400 cells there when normally the hybrid had 96. So
oh, wow. So yeah, so you can get the high voltage with a low capacity if you needed to do a spurt of energy like this, and you need the high voltage for high speed, but also that delivers a lot of amps as well. Cool. So that's an option, and yeah, we're just going to go through all your options. You know, something else we're looking at, I'm very curious about a cheaper solution for EV conversions, but it might not be as popular, which is the Model 3 and Model Y battery pack. And believe it or not, they're actually going for pretty cheap because they don't really fit. They're 5 feet long. Has anybody, do you know anybody?
I was going to say, I think before we jump into that too much, we got to clarify that there's basically like 3 main versions. So actually on the left of your screen right there, go back up to the pictures, please. So that left picture where you can kind of see the pack is sort of half empty, where it says 2021 Model 3 right there. That is actually the original standard range pack, and those are, I believe, 48-inch long bricks. So we have the original standard range, the long range, those are the long ones that would fill that whole tray, and then there's also the LFP standard range one, which is very long as well. But I think the one you're probably going to bring up is the one that's the most seen, the long range with the long bricks there. Now we see it there filling up the whole battery pack there. So yeah, it kind of depends on which version of the Model 3 Y pack we're going to talk about.
And yeah, and you can actually buy the stick separate, so that someone will pull it out.
Yeah, and each one is what's a 96S divided by 4? Are they 20? 26.
7.
38 or 24. 24S. And actually, Omar and I were thinking about fitting one in the Torque, which is my funny looking 3-wheeled vehicle. And we were thinking, maybe they'll fit, maybe they won't. We made one out of cardboard so we can manipulate it without shorting anything out, without lifting up. They're 100 pounds a piece. Trying to lift this thing in there and wedge it. So we made one out of cardboard.
I remember that.
And we were like, it might fit, but in the end, I was like, this is too much of a pain in the ass. I can't deal with this. The Tesla Model S modules are so easy to deal with. I went with that instead.
Go ahead, Joe. What do you got?
I was curious with the group's opinion of are you familiar with the universal boxes by Felton? It's like a 55 kilowatt hour all-in-one. I know they're like super expensive, but the cool thing is I think they have CCS built into it, and which you never can do in the end. I mean, obviously taking money out of the equation. It looks pretty cool from a novice's idea, but I'd love to hear criticisms or what y'all thought. Over.
Well, I think my first question, and then we'll get to Tom's hand here. My first question is, how exactly universal is it? Felton is doing some great things, and there's a lot of OEMs over in the UK doing a lot of conversion stuff. But my question becomes, how universal does it fit in a bus? Does it fit in a Porsche? Does it fit in a Beetle? And then, so Tom,
not so much a question, but I'd love to address your question. And Joe's question, which is, how universal is it? Just because they call it that, it's and the examples you just named were all rear engine Volkswagen architecture, which is a unique architecture, but it's certainly not the only architecture here. If you have a V8 that has an engine in front, this box is the answer, because it'll sit on top of your frame members. And they didn't just pull the word universal battery pack out of their rear end. This thing ticks a lot of boxes, and I would recommend that you watch the video that we put up on our Facebook page, and it's available on YouTube. Let me see, I had it right here. It's an out of spec video done by Jerome, but they talk extensively about the application of this UBP, they call it. It's got its own acronym, and yeah, they're just doing one kind of conversion on one kind of vehicle. They're doing it over and over and over again. So they've got their costs under control. They've got their scheduling under control, and they're killing it, man. It's really the answer for a lot of people.
Yeah.
Oh, look, you can get the CAD model too.
So sorry, Ron. I just brought this up real quick because Tom mentioned it. So this is the Revolt bay of the Mustang, and you can see that there's 3, or I think there's maybe 4 modules up front here. So yeah, when you're configuring your packs and like, where do I stuff all these batteries, and you have an engine bay that was empty, being able to pick a system that is universal and can fit is pretty cool. But with this rear wheel drive front motor with the Revolt system, he's got batteries all over the car. Also, like with the Skyline, the all wheel drive Skyline, he's got batteries all over the place. So being able to have a pack that kind of can fit universally would be really cool.
That UBP is, I believe, a 55 kilowatt hour pack. I don't know what the physical dimensions are, but it fits into the Range Rover's right on the cross members there, right on the frame. So that would be ideal for a lot of builders.
Yeah, this is really cool. There's so many solutions now. A lot of companies working on stuff.
Yeah, I just want a solution for someone who's got no talent like myself that I can just bolt it on. I don't have to worry about a BMS. All the electronics are done. And I think and I want it affordable and like 10 grand or something, is that going to happen in the next 10 years?
Well, we're starting
just because I want CCS. So if you have 55 kilowatt hours, then I can drive wherever the hell I want, at least in California, and not have to have a 4-hour lunch,
Yeah, we're starting to get into that different directions you pull things. Do you want it fast? Do you want it easy? Do you want it cheap? Do you want it good?
I want it all. I'm American.
You can
know?
pick two.
I don't want to
You
compromise.
can only pick two.
No, I think you can. I mean, right now maybe you can't. With unlimited money, you can get everything now. But I think eventually you can get both or get all three. And I mean, I think the Felton is almost there. If you had a catalog of like 4 different products, like a small, medium, and large, and you could get it for 10 grand. That's kind of at least the vision I think we want. I don't know, but I mean, at least what I want. Throw rocks at my arguments. I'm not offended.
No, I think you're right. The Felton is probably one of the first examples we're seeing of the market moving this way of making it more plug and play, more consumer friendly. But there's still going to be the case scenarios.
Yeah, I'm also really surprised where EV West was like the pioneer, and maybe they just got a good thing going. It was like, when are they going to produce like the next amazing product? Is it like in the hidden benches or something?
Well, they have been putting out a lot of the like subframe drop-ins. Like I think they have for Beetle and for Porsche. So like take a Tesla drive unit, which has a differential built into it, bolt it up to this carrier, and then bolt that up to your car. And without any cutting and welding, you've put a Tesla motor in a classic Porsche Beetle. They've done a lot of that, but yes, battery-wise, they could be doing better. Here, let me show you this battery box is pretty slick, but it only holds a 6-pack,
and you have to build it.
You have to build.
Yes. The build process of our project last summer was a big consumer of time and energy and talent. These guys really poured over it. This universal battery pack eliminates all that. But Joe, 30 grand is about as close as you're going to get right now.
I know.
All right.
But it eliminates all that. So, time. Some people say time is money. I don't know.
Yeah, this box is $1,500, and then plus all the electronics in it, and then pay to have somebody populate it for you. But the BMS is inside here as well.
I wonder if the Chinese will produce something that's for 10 grand.
They will.
Well, we're starting to see, they're one of the main sources for LFP packs right now, which they do have. The standard range Model 3 has the LFP packs. So Ron, we've talked a lot about the 18650s from the Tesla Model S, and we started talking about the Model 3Y, and then we have the Felton Universal one. What other examples have we seen of reusable packs? We talked about Johnny's i3 here and there. I haven't seen many Chevy Bolts with a B used very much, but that could be an effective cost option.
Yeah, I mean, we probably should talk about the chemistries for a moment, which kind of dictate some of the sizes. So for instance, you have lithium ion, which you definitely need to manage that, because those are the ones that if you overcharge them or puncture them, they're going to go on fire. Then there's lithium iron phosphate, LFP, which is a lot safer, but not as energy dense. And they're different shape. Am I right? They don't come as a roll. They're only in like a brick form.
So far, I've only seen the prismatic or the boxy ones. There may be some cylindrical LFP out there. I just don't know them offhand.
Yeah. So they're like bricks. And then what's kind of cool is if you design your own pack, you can make it any shape or size you want. So now that we did that, but there's LG Chem as well, which is what Kevin used. Kevin, are those prismatic? Are they pouch? What are those?
They are internally. So the LG Chem, they make a bunch of them, but the Pacifica modules specifically are 32S. They're about this big by that big. That's what Doug's used, and he's going to put 10 of those in his El Camino. They are very energy dense. That's a good option.
They are 6 inches by 8 inches by 14 inches.
Yeah. We've got those in Vicky's Bug too here, the Solar Beetle.
Oh, no way, really? And where are you going to put them in the car?
You talking about me?
Yeah, Doug. Yeah, in the El Camino.
I can show you a picture, but I actually have them stacked 12 inches high, 2 times 6 by 24 inches across, 3 times 8. So there's 6 of them right up against the firewall, and then there's 4 more laying with they're 8 inches tall by 24 wide. So I got a total of 10, and they're going to be 5P 2S on the module. There's 60 fully charged or 67 point something, so that works out to about 330 volts. And
wow,
like I said, I've got a Warp 11 in there, and I've got an old Soliton, which I need to ask some people about, which is good for 342 volts. So it's going to work out great.
And like 1,000 amps, probably.
What I don't have, and I can't seem to find it online, is the firmware for the Soliton controller. If anybody has that, I'm just throwing it out there.
Yeah, that I don't know. But I know I've had that controller in my hand. It's a brick, but it'll take a lot.
I've got two juniors and a Soliton 1. It came with a Soliton 1. I'm taking it out and putting in a junior because I don't need 1,000 amps. And the smaller form factor is better for for the El Camino. I'm also putting one in my Sparrow right now. I just put it in this afternoon. So
the Sparrow.
I have 2 juniors that were actually rebuilt, redone by the designer. He goes on the boards by the name of Tesseract, Tesseract, and I have his. He fixed both of these things for me before 5 years ago. And I just sent him a message this afternoon saying, do you still have the firmware for it? Name is Jeffrey Jenkins. He lives in Florida. So
nice.
Why did your firmware get erased?
I don't know that it's erased, but when you first put it in, it's in the manual. You may need to like reset the controller through the firmware. So when I hooked it up and turned it on, it didn't do anything yet. I need to reset the thing, and for that I need the firmware. I've got a box full of old computers I may have to go through, see if I still have it on there somewhere,
And I think Tom had his hand up from before.
Sorry. Yeah. I wanted to ask Doug, kind of an aside there. What cells did you use for your house bank?
I actually used prismatic lithium that I'd pulled out of my cars. So they're all they were originally 160 amp hour, the plastic, the ones with the plastic shells on them. And they're all as much as 10 years old, but I tested them all individually, and the minimum is 125 amp hours. So I've got 3 of them in parallel, 19S, which works out to 57 cells, about 375 amp hours, about 20.8 kilowatt hours.
Yeah, interesting. So they were degraded by what kind of percentage? Maybe
well, about 120 at 160, so 75, 80%.
Yeah, which is great for a house. Okay, yeah, thanks.
Sure.
Cool. Just to switch gears a little, we recently did an off-grid system. It's kind of like a house on the last episode, and it's the high school build that I did at my high school where I'm a teacher. And we just used rack mount server rack mount batteries, and they're called Ys or Wies. They're 48 volt nominal. They go up to about 54 volts and 100 amp hour. We got 2 of them in parallel. They got their own internal BMS. I haven't even opened them. They have what's nice is they even come with a little DC breaker, so you can switch them on and switch them off. So not everybody's as DIY as they want to be. Like maybe some people are teachers in a school like myself, and you want to keep the kids safe. So there are prepackaged batteries, and these were about $1,000 each. So that's 4,800 watt hours each at $1,000. And they come with their own switch, and they're working out pretty good. We even used a welder the other day. One of the kids had a weld on the project, and it was no issue. We were able to weld with these, and Victron inverters turning that from DC to AC. So there's a lot of options out there. Some of the options are prepackaged. There you go. Cool. What are their house batteries? Does anybody else run in their houses on stuff?
I can figure out how
Your boathouse, your floating house.
Yeah. What about Tom? What batteries are you running?
I have 3 Victron 12-volt 330 amp batteries. They're pretty expensive, but I put them in my boat because I may sell the boat, and I wanted to just make sure that I put, higher end stuff in it for, subsequent. Yeah. And that's the control, the monitor right there. And it's just Victron is a very reliable set of equipment that all works well together. Yeah. I love it.
Yeah, we have the same system. We went with the Victron system. That's the inverters. But as far as batteries, we didn't use the Victron batteries. Do those Victron batteries come with their own BMS?
Yes, of course. Yeah.
Okay.
It's so funny. Like I'm scrolling my Twitter feed, and I have a question in my feed. Does anyone use Victron energy projects for home or RV solar systems? And I'm like, well, that's all I see is Victron is being used with off-grid system.
Yeah. There are a lot. They do.
I survey both, and I see a ton of Victron stuff on boats. Chargers, inverters. Yeah.
Yeah, they have batteries as well. So let's take a look at the batteries real quick, and then we can kind of wrap it up from here. I mean, I think we covered a lot. Oh, there you go. There's Tom showing the let's go back to Tom for a second.
Can I show you real quick?
Yeah.
Yeah. Well, give Tom a second for a sec.
Okay.
So Tom, is the battery management inside the battery, or is it separate?
Inside.
Okay. So each one.
Now I want to point out this little white box down here. Can you see it?
It's a little bit bright. You could shine to the side of it a little. Yeah, there you go. And that's for your alternator, right?
Yeah. So I have a 260 amp alternator on a serpentine belt system on my main engine because, sometimes the sun doesn't shine.
Got it. He's got a solar system. Have you had to use any backup, or is the solar enough?
No, the solar's been quite enough, but I still need to run my engine on a regular basis. So I usually, take the boat out for a little spin around the bay, or just run over to the pump out station, and just a quick trip over to the pump out station to pump off the holding tank and come back will bump my batteries like 30-40%.
Mm-hmm. Oh, look at this. You can even talk to the batteries through your phone. That's amazing.
Yeah. And the good thing about that smart, that brain for the alternator is that it senses what the battery pack needs, but it also senses the load on the engine. So it'll feather itself I say feather. I don't know what the term of it is, but you know, basically not bog the engine down.
Gotcha.
If you're at low RPM, it lowers the charge.
Nice. Oh, okay. I get it.
Up here, he's out in his garage. So
yeah, that's pretty cool. Jose Guran just joined. He's a former student and a friend. He just got himself a Model Y. Yeah, so he's in the club, man. Thanks for joining, Jose. Cool. So yeah, we can kind of wrap it up from here.
Let's take a look at Doug's battery setup. He went out to the garage to show it to us.
Let's see, Doug, and hold your camera horizontal. Perfect. I'm gonna pin you. Yeah, I want to see this setup. That sounds cool. And flip your camera over if you can.
Okay, there we go. Can you see?
Oh, nice.
Okay, so here's the El Camino, right? And here's the LG Chem cells. I just did this yesterday.
Wow.
So there's 6 of them in the back and then 4 of them in the front. And what I do to determine if I've got clearance, you see the dust on there? So what I do is I take a piece of foam and I put it like that. And then I close the hood. That tells me how close I am fitting to various and assorted. This right here was where that was. So that piece of foam was right there when I closed the hood. So you
that's
get
like better than CAD work, better than computer aided design. You got
yeah.
You got FAD, fanned.
Yeah.
It's better than closing a small child in there for them to watch it for you. So
this foam
is a similar trick with a small child over the camera.
This foam, you get this at arts and crafts stores. You know where you stick flowers in a vase, fake flowers, and they stick them into this piece of foam to hold them in place. That's where you get that foam, and it crushes. It crushes, but you know it tells you how much basically space you got. I got about a half an inch, 3/4 of an inch on top of this cell to the nearest piece of the hood there. So
you got to cut a hole in the hood, just like put a blower motor hole in there.
Somebody actually did that before I got the car. That's what that is.
I see.
Piece of the hood frame that somebody chopped out.
That's wild.
The other thing I was going to show.
Yeah, go ahead.
Here's my house setup. Right here. These are all old. See, I made metal. I made aluminum plates to bridge each bank of 3. So, and then there's your positive, there's your negative, and that goes right up to the inverter here, which is a 4 kW Outback.
Wow, that's awesome. That is awesome. Yeah, this is so cool. This is basically hot rodding, and something I've been learning lately, which might sound obvious to Doug, is that the people who are into electric car conversions, they're like cousins with the off-grid house people. The off-grid house people and the car people, they're cousins. It's the same thing, but it's rare that you have a Doug that has done both. You know, there's your new active balancer. That's pretty cool. Yeah. Is that working pretty good?
Yeah, it is. And if it's balancing, it's flashing green. Right now it's flashing blue, meaning that the power is on. If it's flashing green, it's actually balancing actively. It's toward the end of the day, so it doesn't balance until it gets back up to. I charge it from midnight to 6 a.m. because that's when my rates are 13 cents instead of 63. So
okay, stop right there. Let's talk about that for a second. I'm in New Jersey in a rare situation. The town I'm in might be the lowest in the country. I pay 6 cents a kilowatt with no peak, just a flat rate throughout the day in New Jersey.
Wow.
Oh.
And you.
Well, there are some pockets of the country that have like they either have hydro or they have coal or something.
What do you got? Hydro or coal or nuke?
I don't know. I don't know. It's a local company that does the distribution. It's the town that never sold their rights to PSE&G. So it's called Butler Electric. They're doing the distribution, and then PSE&G is obviously going to do the supply, I think. And I don't know what PSE&G uses, but it's probably natural gas. Probably. I don't know. I think
we can unpin Doug at the moment.
Yeah. Okay. Yeah. So I should probably get that prepared for next time. And it's wild. So when I talk about solar and off-grid systems with people in this area, they're just like, yeah, it's not worth it. I'm like, wow. But I know that in California, that's a real thing. What was your rate? Your highest rate? 65 cents?
Well, there's actually two highest rates. One of them is like 63.2 cents, and that's from 4 to 9 p.m.
Peak.
That's peak. There's off peak, which is 41 something cents, and that's all times of the day other than 4 to 9 and midnight to 6. And then midnight to 6, it's like 13 cents, and that's the EV TOU 5 rate.
Yeah, which now that sounds high, but this has actually come down from last year's summer. Last year's summer, the TOU 5, which I also have, was 81 cents a kilowatt hour at peak. So I don't know if they found some pressure or they found a way to not charge so much. So even though that's high, it has come down from 81 cents last year's summer.
And there is one more noteworthy thing about San Diego. They have these in the summertime when you get a heat wave. They have these alerts, and during these alerts, I think it's $1.16 per kilowatt hour, but just on those days.
Yeah.
Wow.
The funny thing is a lot of people use it as an argument against EVs, like, oh, the state of California, I don't want to get too into this, but the state of California is trying to mandate EV, but they can't, you have to turn on. But the thing is, people aren't charging their car from 4 to 9 p.m. The problem is the heat waves and all the AC units coming on and everything. And I know Tom wants to talk about San Diego Community Power right now. So Tom's got
No, but I do want to remind people that the EV, all of that stored energy in a zillion EVs is going to negate the need for a home battery bank. Very, very, very soon. We're actually trying to get a law passed in California right now to mandate that every EV be able to export its stored energy. This is what's going to solve the grid, not kill the grid. So anybody that tells you EVs are going to kill the grid, they're just totally ill-informed.
Right. Yeah. So that's the thing, is there's a lot of commingled or conflated arguments going on here. So Ron, you were talking about the EV converters and the off-grid people are cousins. So last week we talked about how I saw polydrops, and I wanted to share that I actually now have my episode out on my channel. We have the polydrops trailer has Aptera solar on the roof, as well as EcoFlow batteries in the trailer. So right here we have Aptera solar panels, 1.3 kilowatts of solar on the roof, and they're going to have the next gen production glass panels after this when they actually go to production. But they also have inside an EcoFlow. There's the panel for the EcoFlow. It was running air conditioner in the fridge all day long over here at Electrify Expo. But EcoFlow has a nice little package you can put together too, with a little screen and everything. So there's a lot of companies doing this, modular systems. You can go from a very small system up to a very large system with all these different brands. But anyway, that episode is now finally out on my YouTube channel, Charge Positive. Check out Polydrops with Aptera Solar.
Great episode too, Tulloch.
Thank
really
you.
Well, yeah, well done.
I found the rates of Butler Electric. You guys have to see this. Just to make you mad. I'm sorry. This is the rates right here. You see this? From 16 to 2,000 kilowatt hours, you're at 6 cents.
I love how I love how this is based on bulk buying. Like this is the Costco of electricity. When you buy more, it goes cheaper as opposed to more expensive. if we use more here, if you like the old system before there was time of use, you had these tiers, and if you used more than your neighbors did, you got bumped into a higher rate of paying, not a lower rate of paying.
Amazing. Yeah, I don't know. I think I guess they get it from yeah, I don't really know much about it.
What's your bill?
I haven't got it yet. This is a new space for me, but I live close by with my girlfriend, and I've been charging. I commute a lot, about an hour each way, and I charge my Tesla. Total with the house and the car for the month was $100. It was like $92.
Wow. Yeah.
Amazing. That's not. I can't believe it. I don't understand.
You better run out and go get solar right away.
Yeah, before they bump it up.
Last summer I was about $250 a month, and I figure I did the math, and this is going to save me about $130 a month.
Wow.
Just got it online about 2 weeks ago. So
yeah, amazing. Cool. All right. Well, this is pretty good. I really appreciate everybody being here. This is an incredible community. There's more to come. I like that we got to see a lot of projects and tours. Doug, that was a great addition to the program. Thanks a lot. Appreciate it. And we also have Kevin and Omar and AVLC. And we got Richard Jones. He's regular. Joe Roth is coming in. And we obviously got Tom Summers coming to us from an off-grid system, his boat. And Talik coming in with the examples. He's got the great examples. So cool that you went and go see that trailer. And you can check it out on your channel, Charge Positive. And what's the other channels that you've been doing work for?
So Gas and Go Snow, I'm helping him edit and film for him sometimes. So he covers a bunch of cool, basically hot rodding 2.0. Eddie from Revolt, that's what he's calling it now with the EV conversions. Also, I help out with fthepump.com, their YouTube channel. But Ron, what's coming up this summer that we can look forward to?
Yeah, so I've got classes here. You could take Intro to Welding, Intro to Mechanics. There's going to be an electric car class, and then also don't forget in California there will be a class, an EV conversion class at the EVLC.
And there's something happening in July, right? What's happening middle of July?
Oh, are you talking about what's happening in Colorado?
Yeah.
Oh, Colorado, we got Ohm on the Range. That is going to be an EV show. I think I'm going to make it. I'm going to call Terry. We're going to talk about it. So that'll be pretty cool. A lot of EV enthusiasts, conversion enthusiasts, and that's what's coming up. So, yeah, stay tuned, and see you guys again next week.